BlueTech Around the World, the reference podcast for blue technologies and ocean innovation. Hello everyone and welcome back to BlueTech Around the World. Today we are diving into ocean observation and the amazing technologies that are reshaping our understanding of the seas. From digital tools and robotics to artificial intelligence and biotechnologies, these advances are helping us learn more about ocean health and sustainability. And today I'm thrilled to introduce our guest, Dominique Durand. Hello, Dominique.
Hello, Marilu. Very nice to be here, and thanks for having me.
Dominique is a true leader in marine science and sustainable blue economy, with over 20 years of experience in ocean monitoring, research, and innovation. He's the founder and CEO of BlueTech in Norway, where he leads consulting work in marine research and technologies. His background includes significant roles at the Norwegian Institute for Water Research, focusing on everything from ocean observation to cutting-edge satellite-based systems. So, Dominique, welcome to the podcast.
Thank you very much. Thanks for having me.
Dominique, to start, can you share a bit about your journey? What sparked your passion for ocean observation?
Yeah, of course. Yeah. So actually, ocean observation is part of my career all the time. You know, when I got 50 at some point, I looked back over my shoulder and I thought that actually the thing that was carried out throughout all my career was actually ocean observation from very, very different perspectives. Starting from space, actually, and going to the ocean after that, going to microbiology and biotechnology afterwards. So looking at this aspect from very different angles, actually.
Yeah, actually, it's great. It's why I choose you as a guest for this podcast, because you have all these different angles to see how ocean observation can help us, as you were mentioning, through spatial, through biotechnologies, robotics. I'm really looking forward to see all of this with you. So first, to kick things off, let's explore the basics of ocean observations. Dominique, could you break down what ocean observation really is for our listener, like the basic definition of what is it?
Yeah. So basically, what we call ocean observation is trying to get information about the state of the ocean by looking to different parameters, different variables that defines the environment. Would it be the physical environments? You can think about the currents, you can think about the temperature of the sea, the salinity, and this. But it goes also to the chemistry, what is happening with different molecules and discharge from land in the ocean, can be pollutions and so on, but also the biological state. So it means how living organisms are basically interacting with each other, responding to the environment they are living in and how they develop or how they disappear sometime. So it's gathering information basically about all this for the sake of science or for the sake of sustainable development or to develop policies for protecting the sea or developing activity at seas, etc.
Okay, so in other words, ocean observation is like having a detailed health checkup for oceans. It helps understand everything from marine life to water quality and helps people making decisions, whether for economical activities, scientific research, or policy. Okay, great. You have us on a good track for the rest of the podcast. So, this podcast is really focused on innovation and new technologies. And we know that technologies has transformed so many fields. And how has digitalization changed marine observation over the past decades?
I must say that digitalization is changing ocean observation right now. But now we are in Industry 4.0. And Industry 4.0 is about Internet of Things, interacting or making sensors and technology interacting with each other. It's about edge computing, cloud computing, and automation, and the new step in robotics. Observing the ocean, it means a lot going at sea. Going at sea, it means having a big boat going there with some footprint in terms of carbon dioxide impact, for example. And all these aspects of the Industry 4.0 and the digitizing and the automation and robotics are or should and will bring much less need to go at sea. and having a very positive effect also in minimizing the time that we need to have at sea, even if it is for an oceanographer as me, it is of course paradise to be at sea, but we have to think also bigger picture, and this is one of the impact among many actually.
Yeah, it's true that we hear a lot of about the Internet of Things, so IoT and also robotics, underwater drones, and how they help us gather more precise data from the oceans. But it's true that it's interesting to talk also about the impact. You were talking about the environmental footprint when we go at sea. I can also say just the risk of being at sea and economical cost of being at sea and the time. So, yeah, I think it's really important to also have this information in mind when we think about gathering precise data at sea. Tech around the world. So, as you mentioned, different kind of sensors. I was wondering, how does it work exactly?
Okay, so there is different key challenges to be consider. And of course, the ocean is very deep, and you can deploy the instruments and sensors in the coastal area, easily accessible, and so on. Or you can deploy it at 3,000 meters deep in the middle of the Atlantic Ocean. But I would take one example to start with. A very simple example. One thing which is happening now is developing autonomous vehicles, so autonomous platform with sensors on board that can move in the ocean with a programming, basically. And what is developed now, if you think this modern vacuum cleaners going around your house like little robots and getting back to be docking to recharge when needed, it is exactly what is happening in the coastal observation world. Is having autonomous vehicles that can do their missions pre-programmed or steered, coming back into a docking station where they can recharge, but also when they can deliver the data by cable or by through satellite near real time, which is key in many aspects, not always, but that can be key in many applications actually. So this is one concrete example. Think about these vacuum cleaners, and that's what is developing, by the industry, especially. You can think the oil and gas industry, but also the offshore wind industry and other type of industry exploiting also or operating in the oceanic environment, basically. So so this is one thing. The docking station is a machine. The autonomous vehicle is another machine that have to communicate with each other, with all the challenges of communication underwater, because the sound is not propagating the same way in air and in water. So you have a lot of development lately, also on the pure communication underwater to make this aspect happening with the right distance, the right range between the different instruments that has to interact with each other, basically.
So it's really like an underwater Internet of Things. So as you mentioned, as it's a specific environment underwater, you have to adapt all the Internet of Things that we have on land, underwater, with this specific communication process with underwater acoustic, for example, or cable. Okay, yeah, thank you for this great example, Dominique, that give us a little test about what is actually IoT and robots and how this automation can help us gather data in some specific site.
I can give you another example, completely different, if you're interested in.
Yes, please do.
So some variables, some parameters in the sea are extremely difficult to measure. Until now, are just measured in laboratory. So it means that you have to go at sea, you have to take a water sample, fixing or preserving this water sample in certain ways to come back and make analysis in the lab. Just like if you were taking, a blood sample at home and is going to the lab for analysis. So it means that for this type of parameter and variables, and it relates very much to biological parameter and chemical parameters, so then you have very, very few samples. You cannot be at sea and you cannot be everywhere at sea to sample at the right frequency in space and time, actually, to have a good understanding of what's going on. And there is a cost, of course. So what is developed is automatic water sampling, but that can go very far. So it can be you sample the water and you have a robot that can extract what we need, what you want to analyze from the water, preserving this, And then you take that back on the boat and then back to a lab. But it means that in between, you are able to make a lot of samples at a very high frequency. And this is actually increasing drastically the number of observations that we have on certain parameters that was completely limited to lab analysis until now. So it's still lab analysis, but the sampling has been automatized, enlarging the amount of data and information drastically.
That's really interesting. And actually, it's a perfect transition from my next question because with all this new data coming in, we are at the era of big data. Artificial intelligence could play a huge role in that because they can really make sense of all this ocean data that you are talking about. So, according to you, how artificial intelligence and automation help us tackle big issues that are facing the ocean?
So I will make the link first with what IoT is enabling in terms of artificial intelligence. So I've been giving you some examples before. Now let's think about another example. You have a sensor measuring certain parameters, but that allow you only to take 20 samples before the sensor has to be taken back on board. So now if you have a network of sensors gathering data, and if you have the capacity to compute and to analyze the data on board through artificial intelligence and to infer if the situation we're observing is normal or if it is abnormal. So then you can think something is happening, an event is happening. It can be an algal blooms, it can be certain pollutants coming, some temperature change. AI can allow you on board to make this assessment automatically and for the system itself to take decision. Possibly, actually, one of my sensors is not working appropriately, or possibly one of my sensors is full of fouling, a lot of algae, and is not measuring right. And then I have to maintain this. But you can also possibly say, no, actually, my sensors are working well. Data show me that actually the sensor is not the problem. Then something really is happening in the environment. And then you can decide that this sensor I was mentioning at the beginning, it is not online all the time. It is just triggered when needed to increase observation and increase information on a specific event happening. This is what we call IoT-enabled AI, is the possibility to look at the condition of your system and the detection of specific events and taking measures toward that to increase the understanding of what we're observing.
Okay, so an Internet of Things really intelligent, as you mentioned. So checking if there is a problem in the system in itself and saying, okay, I need to go to maintenance and clean for biofouling, for example, or making some intelligence decision saying, okay, there is a problem right now. There is something not usual. So maybe I will need to increase the frequency of the samples or the data collected or changing the road and the circuit of the robots for taking the sample according to the new data that is incorporating. So
Exactly. And there is a lot of developments and the trend is there and is going to be one of the future of ocean observation, going also more automatization, less time at sea, less interactions or involvement of humans. So, which is absolutely crucial if you think about things at 2000 meter depths where people are not going. As you mentioned yourself, automation, robotics will increase the number of data. And of course, you have to find new tools to deal with that. So artificial intelligence are a way of doing that. But the other aspect of it is the development of what we call digital twin of the ocean, a digital platform or model that allow us to forecast, to run scenarios. So if I do that, how the ocean is going to react, the physical ocean, the chemical ocean, and the biological ocean. And if a lot of things are in place when it goes to the physical ocean, so it means temperature, salinity, currents, waves. So there is already very good models. But when it goes to chemical, biogeochemical, and even more to biology, actually, we don't have good models. And it's very complicated to have good, standard model and trying to simulate the biology, something extremely complicated. But there, AI can really give new opportunities. If you have enough data, that are representative to any kind of situation so that you can train your AI platform appropriately. But the good thing with AI is that it is also made to be trained continuously, so that you can start with a set of data that give you a first capability in your AI platform. And as new data are coming, you improve, and you will have a model that will give you more and more good results as it develops. The main point is that AI could give access what if scenarios and even forecasts which are not available at all now. And the digital twin of the ocean is one of the main incentives actually to develop these aspects.
Thank you, Dominique, because it's really interesting. We hear a lot about the digital twin of the ocean, etc. But here you really give us some insight of what are the real implications with this digital ocean regarding scenarios, making decisions. And one point that is really important is that you did the difference between all the physical parameters that we used to have a lot of data, and because the sensors that we were talking about just earlier are really focusing on this kind of data, and that everything regarding to chemical, anything related to microorganism, these are like the data that we have more difficulty to get, and so that are not really implementing in the digital twin right now. And actually, it's again a perfect transition for my next question, because we were first focusing on robotics, IoT, sensors, so something like really concrete. But now I would love to hear about what is biotechnologies, all these new tools for marine observation. So, Dominique, can you give to our listener a quick overview of how biotechnology fits into ocean science and could be a good tools to have other kind of data?
Yeah, so for me, biotechnology is just another revolution parallel to the industrial and robotics revolution. And I will try to demonstrate that the two are very much linked, or should be linked actually, to provide the capacity that we can expect from biotechnology. But biotechnology is using living organisms as technology, as sensor, or using technology to infer what biology can give us as an information on what is happening in the environment, for example. So something that has been blossoming the last years is what we call the eDNA, or basically any organisms has DNA in the cell, and when the organisms die or release something in the environment, there is DNA in that. So it means that in any water sample you take, there is DNA coming from the living organisms which are in the neighboring, from bacteria, let's say, to fish or to whale.
Okay, so with eDNA, we are able to detect what kind of species are present in the water, almost like a fingerprint of marine life without even seeing them.
Yeah, exactly. So basically, eDNA, or the environmental DNA, is used for two main things, if I would simplify right now. It can give, by screening the DNA in a sample, you can have an indication on what was there or what has been there at some point, which is an indicator of biodiversity. And you can have a relative abundance of the different species or different type of organisms in a sample. So this is one application. The other application is you can trace one specific species. Let's take an example. We have, we know that an algae can be very harmful sometimes. So you have harmful algae blooming from year to year, and having a lot of impacts. Can be on the mussels, on the oyster, but also on human health. These algae species are known. Their DNA, which are not very complicated because it's algae, can be sequenced, and then you can follow, or you can try to look in your samples if this specific DNA or part of the DNA is present or not. So it means if you want to follow or to monitor harmful algae, if you want to monitor some invasive species coming in your environment, or some species that are in danger of extinction, so then you can use eDNA to trace some specific species. So you have these two aspects, the broad analysis of what is in there, or following, having some specific monitoring. This is two applications that are developing now.
Yeah, I really feel it like if we are investigators looking for clue in the water, trying to follow some specific species for different kind of application, as you were mentioning, preservation, for example, if it's an endangered species, or like mitigation system, it's for a harmful algae bloom or invasive species. So yeah, really interesting. I know that there is more than eDNA because I know you particularly focus on what's called the bacterial factory. Can you explain how this approach is revolutioning our monitoring abilities?
Yeah. So eDNA was one example because it's really what's going on now and what people can hear in the media. The other part, which is much less known because it's less mature, but is coming, is using living organisms as sensor. Let's say you take a muscle, you equip the muscle with some sensors that measure how often the muscle is opening and closing. You know what we call a valve gap. This information is very much correlated to how the muscle react to its environment. And if you have pollutants, the stress of the pollutants to the muscle will make the change of how the muscle are going to basically open, close, and so on. You can also take a crab and put a sensor that measure the heart rate of the crab. The heart rate will also be related to the environment and changes the environment. And then you can use that as a proxy of what can happen in the environment. So this is using the whole animal.
So, if I understand, Dominique, you are using species in the marine environment as a reactor, a bioreactor, to better understand the parameters of the environment. So, you give the example of mussel, of the crabs. I know that there are also some sensors sometimes in the fish to measure the stress, to better understand if there is a problem in the environment. So, really using the natural behavior of the marine life to
Exactly.
better understand the environment. Okay.
Yeah, exactly. What this says is always complicated to relate this behavior to specific stressor and to quantify the stressor in terms of abundance or concentration. But anyway, it can give an early warning of that something's happening to be able to deploy other technology and other approach to get to the bottom of the problem. Another things which are appearing is using bacteria. So bacteria are eating basically on what is in the environment. Some bacteria are eating on oil. So it means when you have hydrocarbon, an oil spill, for example, you have some certain bacteria developing and other bacteria disappearing also because of it. So it means that using back the eDNA and looking at the diversity of the bacterial communities, basically what type of species are increasing, decreasing, you can definitely have very concrete information and even quantitative information of what's going on or if a specific stressor has been or is in the environment at the time being, and especially when it is chemicals, which are, as I said before, very complicated to measure automatically at sea. So it can be a way of having a proxy to infer this type of pollutants. So this is one application of how bacteria can be used as communities, looking at the diversity. The other thing is that bacteria are very simple organism, one cell, so we know change or manipulate the DNA of a bacteria to make this bacteria doing or measuring something that we want to measure. So we take a bacteria and we change the DNA to have a signal if some specific contaminants, let's say an heavy metal, a cadmium, for example, is present in the environment. And then you can deploy this bacteria in a sensor at a specific location to try to measure actually what a specific compound. So this is done in laboratories now. It's not done in sensors that can be deployed at sea until now, but the development of what we call the microfluidics, so it means the way of having waters circulating in a very small chip, basically, and with some reactors that can make the possibility to measure things on a very, very small scale. So it's very developing. It's what we call also the lab on chip. So basically, we take the lab and we put that on a little chip, basically, to make the same kind of measurement we are doing in lab. So if you connect this lab on chip and microfluidics technology with the capacity to engineer a bacteria to measure something specific, so then you start to have a biosensor that will be specific to measure some pollutants, some contaminants, something that we cannot measure at sea with other manner than with that. The path is a bit long still on that, but everything is in place to be able to do that in the future. And I think this is going to become true in the next 10, 15 years. It will require time, but it will be a game changer.
I really love the example that you are giving about the lab on chip. For example, right now for ballast water, it's also a way when we analyze the water in the ballast to see what's going on the way of the boat to come with invasive species, for example. But I can see right now the amount of application if we can have like this kind of sensors with already the water reacting with this bacteria and microorganism to detect what's going on and to help react.
Yeah, the implication is almost infinite, or you can just imagine with this aspect at the basis what you can do actually. So it's enormous. If you want me to conclude a bit on this part on biotechnology, I would like to relate that to what I said before on IoT, digitalization, AI. So typically, biosensors will always be limited in terms of samples that can be measured because basically you have to have one lab on chip for each sample, or sometimes you can clean it and use it using it several times, but it will be anyway limited, to something as 10, 20, 30 measurements. So, and in this case, deploying this type of technology that can have very strong impact to measuring and observing specific things in the ocean are very much linked to the possibility to steer their functions or their activation, basically. It's not something that you can just measure all the time. So it will have to be used when we think that something is happening and when the measurements may have a value. And then, yeah, coming back to the example I gave before, it's a very clear example of if we can measure a high frequency, some parameter, making AI type approach, inferring what's going on to trigger something else as these biosensors in the future. So then you start to have something, a system that can work and really give you what you can expect.
Yeah, the combination with what I will call traditional ocean monitoring with all these samples and what you just say, observe right away and give us faster insight into how ecosystem responds to things like pollution or temperature shifts. So yeah, these two approach give us a more global and reactive way on how to understand the ocean. So yeah, that's great. Thank you. This actually sounds really promising, but I'm sure there are some challenges too. What are the biggest hurdles in using the bacterial factory approach? If there are any technical difficulties in working with this microscopic organism at such a large scale, what are your biggest challenges, according to you?
There is a prototype already of this type of technology, especially the Monterey Bay Aquarium Institute, MBARI, in California, is leading in developing this type of approach into platforms that are deployed at sea. It's a very complicated technology at the end, sometimes not with the level of robustness that is needed to function on the long term at sea, because sea is a harsh environment from time to time. So, and it really required also a lot of robustness in the technology deployed. There is a cost. It will never be cheap technology, so it's something complex. But so it's really about the value of what it brings. Costly, but not costly at all compared to a week at sea with a research vessel to take samples and coming back to the lab. So everything is relative. And of course, there is some cultural barriers in the scientific community. One of the barriers is to convince some scientists to go that way, and to have at the same time the industry that can develop this type of technology on board and having a sustainable business model around that. And certainly at present, so it's a limiting factor. But there is more and more industry and small companies really looking at that and seeing a future into that. And there will be a lot of pressure anyway to increase our capacity to observe the biology and the chemistry automatically and on site and in real time in the future to support the sustainable development of the blue economy and taking the right decision on the right investments and the impact of one option to another. So,
Thank you very much, Dominique, on that insight. So we cover the IoT, robotics, all the new tools that we have for observing the ocean. We also talk about all the blue biotechnologies. Just a few words about space technologies. Tech around the world. I know from some of our listener, they don't really understand why I'm talking about space in a podcast about ocean, but we know that satellites help us understand the oceans and tackle some issues like coastal erosion, pollution, even illegal fishing. So, can you give us a little information about that?
yes, yeah, I will try to be short, but it's a complex and a bit broad topic. But basically, there has been satellite dedicated to Earth observation since the 1960s, basically. And of course, the technology are progressing, and more parameters can be measured from space. Why are we using satellite to do that? Because when you have a satellite orbiting the Earth, they can look at the entire Earth at some point. So this is one thing. So you can see all the Earth. Global observation that is never possible with boats or with other technology. So this is the first big benefit from satellite. With satellite, you only see the sea surface or the upper layer. You cannot have information on the deeper ocean, but you see a big area. So if I compare with some measurement we can do from a buoy, for example, where you put a sensor on a buoy, a temperature sensor, you have measurement only at one location every 30 seconds, for example. This is what on-site observation can give you as an example. Satellite will give you the observation of a much broader area, but you will see that only every 3 days or every 5 hours, depending of the orbits and the satellite technology.
Okay, so yeah, the two, it's really the difference between the frequency of the data that is recording and the area that is monitoring. What it would be interesting to measure like such a big surface. Can you give us some application about that?
So first, not everything can be measured from space. Just to give you a concrete example, if you are using an optical sensor on board a satellite, so basically the sensor will measure the part of the sun radiance that has been reflected by the Earth and coming back to the satellite. So what you are measuring, it is the interaction between these wavelengths of electromagnetic waves with the environment, and so you are inferring what is there depending of the signal you are measuring. So it means that the number of parameters is limited. But example of those are sea surface temperature. We use sensor using the thermal infrared part of the spectrum to measure the temperature of the surface of the sea. It's the very first millimeter of the surface, but it gives you the temperature of the sea everywhere. This is already used operationally in ocean forecasting model as an input. So satellite data is already used operationally to drive or to constrain or to forecasting model of the ocean to better predict basically especially the physics of the ocean. Another parameter which is measure is which is infer is the amount of chlorophyll. Chlorophyll is this molecule which is in any plant, basically, or any vegetal, including algae. So basically, by measuring the chlorophyll A and sometimes other algae pigments that now we know how to measure also from space, so you can infer what not species, but at least what type of what family of algae is present there, for example, which can link to harmful algae or to specific dynamics of ecosystems. So this is another example of very used and broadly used parameters acquired from space.
So if I sum up, depending of the kind of parameters I want to monitor, the surface, the frequency, also the cost. It's not the same cost to use a satellite sensor in situ or what we were talking about, microbiological sensors. We will use these different technologies. And what you were mentioning also before is that they could all be complementary and bring different angle on the same understanding of the global ocean. And I think it's really important that with so much data collected, that to make sure that they are useful and accessible for scientists and policymakers. And I know that there are some projects with the Marine Copernicus program, for example, to have some open source data to help people to make better decision and to understand and to protect or valorize the ocean.
Yeah, if I may just reflect to what you have just said. So one of the key challenge that we have now is, especially between observing on site or observing from space, is are we measuring the same thing? Are the parameter we're measuring that we are possibly calling the same comparable, and can they be used together? Until now, modeling has been a big important tool to use this different source of observation from space or in situ and making scenarios or understanding or forecasting. And it was used independently of each other. Now, with artificial intelligence based model, which is database model, so basically we see that data can come from on-site observation, data can come from satellite observation, data can come from model simulation. If we want to make an AI algorithm working with that and providing information and solutions and decision, all these data are to be compatible. And this is one of the big challenge that we have now that has been there for all the time, but now which come as a critical barrier to overcome to develop and deploy the full capacity of AI approach in the context of the digital twin of the ocean, for example, more generally. Having consistent data that can be used together to provide actually real information into an AI algorithm and not noise because everything is based on the input output, but if the data you provide actually are of different nature, you call them the same but actually they are representing something different, it will be very complicated for the algorithm to find its way and to find solutions. So one thing is to have all the data in one place available to everyone, but the first thing is to be sure that the data that will come into this data lake will have the consistency is not only about the quality, but the consistency that actually will allow to make the best out of those.
Yeah, yeah, completely. Thank you, Dominique. So, as we wrap up, I just want to ask you a last question, just a little insight. If there is any trends or technology we should keep an eye on regarding ocean observation in the next few years, you already give us some example, but what's your favorite one that we should keep an eye on?
Possibly, I would say the one which is the least advanced and that possibly for me has a very underrated potential, and it is this bacterial factory, the capacity to engineer bacteria to make them sensors and measurements of specific things in the ocean that we are not able to measure operationally at the present time. So here there is a field of creativity and application that I think is tremendous and underrated, I think.
Mm. I really love your answer because actually, my consulting company is Blue Connection. And what I say always about Blue Connection is innovation for and by the ocean. And actually, we are really in the by the ocean, where it's really the ocean that bring technologies as a new center. So yeah, that's great. So thank you so much, Dominique, for sharing this fascinating insights. For our listener who want to follow your work, where can they find more information in your LinkedIn?
So the easiest way would be through my LinkedIn. The easiest way to get in touch, I think.
I will put your LinkedIn account under the description of the episode, like that, if they want to reach out to you. That's the easiest way. So if you enjoy today's episode and want to stay updated on the latest in BlueTech and ocean innovation, make sure to follow BlueTech around the world, subscribe, share with your colleagues and friends. And again, thank you, Dominique, for being here with us. It was a real pleasure and really interesting. So thank you very much.
Thanks to you, it was fun to express some of my thinking and views. So it was great. Thank you very much, Marlo.
Thank you, Dominique.
Tech around the world.